Hello, hello, hello. Welcome to lesson number 7, area of composite shapes. So the topic is area and surface area, and we're moving on to shapes that are wonky. These are wonky shapes. You can't just, like this little weird shape I've drawn here, you can't find the area of that with a simple formula. You can't, because it's not a rectangle, it's not a square, it's weird. Look how many sides it's got, its shape, it's all over the place. But it's made up of things we know. It's made up of rectangles. So we split it into rectangles, we can find the area of it. But there's two methods that I want you to keep in mind here. One is the addition method. We split this up into two rectangles. There's the rectangle here in pink on top, and then there's the rectangle here in gold on the bottom, and you find the area A1, you find the area A2, and you plus them. That's the standard way to do things. But there is a tricky way. I just want to show it to you in case you like it. It's subtraction. It's pretend you had a really big rectangle in red, and then you took a chunk out of it. That little small rectangle, you just took that out of it. So if you found the area A3 and then take away A4, that works too. You'll see it. You'll get the same answer either way. Just thought I'd show you that right at the start, but most of the time I'm just going to do addition. All right. Now I'm going to go on to page 43. I'll give you a little countdown. 3. Down we go. Area of composite shapes. Composite shapes are when we are given an irregular figure that is made up of regular shapes. That could be written better. That's confusing. Composite shapes. The shapes made up of regular shapes. That's it. And there are two ways. Adding, whoop, that's in the wrong place. Adding, subtracting, just like I explained. So this example 1, how am I going to do it? Ooh, I could add, this one is actually maybe subtract. No, I'm just going to go addition. Just stick with the standard way. So we have here, I've made my little cut. I'm going to call that, I'm going to give it a name. That's A1. I'm going to call this one A2. And the formula for that one, length times width for both of those. But now we've got to check. All right. Do we have the length for that one? For the A1? Yes, we do. The length is 8 meters. The width is 5 meters. For this bottom one, the length, we say the one on the bottom, that's 4. Length is 4 meters. But the width, is that 11 meters? Nuh-uh. 11 is all the way from there to there. And that's 5 from there to there. So we need just that bottom bit. So the trick is 11 is the whole thing. Take away the top bit is what we're left with is the bottom. We're going to do that a lot. So they're going to give us that whole side, but that ain't right. Oh, how did I do that, by the way? Because I'll put it here in green. If that's 5 on the left, then that's 5 from there to there. So 5 plus what gives us 11? 6. Little point there. Okay, so now I can just do it in one step. Go in red. Area of the whole thing. It's A1 plus A2. That's too messy. Why am I so messy today? Let's A1 plus A2. And the area of the top one is 8 by 5. And the bottom one is 4 by 6. 4, and the calculator can do the rest from here, but that's 40 plus 24, it's 64. And it'll be meters squared. And just in case you don't trust me, 8 times 5 plus 4 times 6. And I have got stuff wrong, but not this time. So I like to do it that way. There's more than one way to do it, but I like to set everything up and then the calculation's easy. Otherwise, the calculation is so long. All right, I'm going to scroll down in 3, 1. Down we go. Lots of examples. 3 more examples for you. Got to do the same process. Give things a name. A1, A2. Names are so useful. Now, the bottom one's easy. It's a rectangle, length times width. And I'll say straight away, and we got enough green this time, length is 8, width is 5. Not a problem. But the top part, it's not a full circle. It's a semicircle. So it's a sector. So it's half a pi r squared, or we could do it this way. This formula always works. Theta on 360 times pi r squared. Where, in green, the theta, what angle do we have? We've got 180 degrees. Half of 360. So if you do 360 divided by 2, 180. Or you say 1 over 2 times 360. If you forget. So that's 180. And what's the radius? Have they given us the radius? No, they've given us 8 is from all the way from one side to the other. If that's 8, we want the radius, which is just from there to there. Half of 8 is 4. Again, same process. 8 divided by 2, or you could do 1 over 2 times 8. Whatever you like, or do it in your head. And that's 4 centimeters. I should put that in here. Length 8 centimeters, 5 centimeters, and R is 4 centimeters. Whew, that's the hard bit. So then the quick bit is just writing out what it is. So area equals A1 plus A2, and it's 180 on 360 times pi times 4 squared, pi r squared, plus the length times the width, 8 by 5. That's going to be messy. I can tell you what it's roughly going to be. Because 4 squared is 16. Pi is just over 3. 3 times 16 is 48. So that's going to be about 50. 180 over 360 is half. Half of 50 is 25. So that's 25 on the left. 8 times 5 is 40. So it's going to be about 65. But that is, good to know. But totally not needed, because the calculator, as long as you put it in right, will do everything for you. And it was just over 65. And I will give you that, 65. Well, it doesn't give it doesn't tell you how many decimal places to do. 2, 7, 4, 1, 2, 3. Let's go just 65 centimeters squared. We'll say nearest hole. So that's how we do these. All right. Now, next one. This is definitely a subtraction situation. Total gimme for subtraction. Area in blue around the outside is, we'll call that one. It's easier than the last one. Last one was tough. We'll call that one A3. And in the middle, and gold. No, not gold. Gold's too hard to see. Keep using the same colors, but red. In red, A4. So we're going to find A3, the whole thing, and subtract the hole that's been taken out of it. This first one is very straightforward. Wait, I'm just going to change. Oh, no, just do it over here. I'll do it this way this time, because we're a bit short on room. A3, it's length times width. The length on the bottom of the whole rectangle is 10.5 meters, and the width is 7.5 meters. A4, on the other hand, to do it over here, is a triangle. Formula is half times base times height, where the base is 6.7 meters and the height is 4.6 meters. Everything's in meters, everything's set up, we're good to go. So we can say single step area equals A3 minus A4. A3 is 10.5 times 7.5 minus half times 6.7. That's about 6. Looks like a 1. Times 4.6. Calculator, done. So this way we only have probably 4 lines, right? You write down how you're going to find the area, and you show the numbers, then you write it out, then you round it. 10.5 times 7.5 minus half times 6.7 times 4.6. Before I press equals, I'm going to check it. 10.5, good, times 7.5, good, minus half times 6.7. Check, 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 complete. 63.634. That's exact. I'm just going to leave it like that. That's okay. Oh, all the measurements were at 1 decimal place, so it's kind of nice to do that to 1 dp as well. All right, one more example. Oh, another tough one. This one's going to be 3 parts, definitely. 3 here. We will go orange. We got you over here. A1. Then in the middle, pinky, A2. Bluey, unintentional reference to that TV show, A3. So let's set it all up. A1, that's a sector, so our formula is theta over 360 times pi r squared. The angle, theta, 60. We need the radius. That's actually the 5 there. The radius of the circle is 5 centimeters. Good. A2, it's a rectangle. Length times width. Length is 10 centimeters. Width is 5 centimeters. We're set up. A3, another sector. Theta over 360 times pi r squared. Theta is the angle there. It's a right angle, 90. Now the radius, they didn't make it clear, but if that's 5 on the right, on the left here, 5 centimeters, then that's got to be 5 there as well. We're going to assume that. It's a safe assumption, but they really should give it to us. Put some sort of symbol. All right, we are set up. Okay, so you could find all 3 of them separately and then plus them together. That's going to take longer. So I know it might be scary, but I'm going to do one biggie. A1 plus A2 plus A3. Going to do it all in one color you can see. A1 plus A2 plus A3. Again, you can find them separately and then add them up if you want, but I'm going to do it this way. 60 over 360 times pi times 5 squared. That's 1 down. Plus, I'll do it over 3 lines so it's less scary. Length times the width, 10 by 5. Plus, one more crazy one. 90 over 360 times pi times 5 squared. Equals. So spreading it out. It takes a lot of, these questions take a lot of space, and then it's epic calculator time. Without a calculator, this would take so long, but calculator will do it all for us. Super quick. I mean, like, I wonder how long it actually takes the calculator to do these calculations. Whoop. It's about to do it again, aren't I? There we go. Times pi times 5 squared. Check time before I press equals. 60 over 360 times pi times 5 squared. Good. Second one is 10 by 5. Good. Third one is 90 over 360 times pi times 5 squared. Good. Equals. It's under milliseconds. It's got to be like microseconds, nanoseconds. Who knows? They didn't tell us what to do it to. I'm going to write the answer. 80. I'll write the full thing. 82.72492347. Dot, 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 dot. I'm going to just go nearest hole. 83. That's all in centimeters. Nearest hole. Ta-da! That's a whole scary page, right? We have just gone from easy stuff to hard stuff very quickly. Very quickly. Hopefully the examples aren't so tough. All right, I'm going to pause in. 3, 2, 1. All right, good news. The examples are so much easier than those ones. Oh my God, these 3 examples here, tough. They're all more like the first one. Much nicer. Good. All right, I'm going to scroll down. And here we go. All right, try these on your own. Copy these diagrams. Draw a dotted line. I'm just going to do the one on the left each time. Draw a dotted line where you might divide these shapes. Hey, A is a bad one. That's a trapezium. You don't need to divide that baby. B, also a trapezium. You don't need to divide that baby. They want you to say this, though. They want you to say, oh, we should split it here. But you shouldn't. It's a trapezium. And they want you to say, oh, you should split it here. But no, I'm going to remove both of those and say, no, silly. C is one we'd actually do. Yeah, you're going to split that one up into trapezium on the left and a rectangle on the right. And you'd split them up and then you'd plus them. That's legit. The other two, bad examples. Find the, which one? Addition or subtraction? That one, A, definitely addition. Man, I said I'd just do the ones on the left. B, what do you think? Nah, obviously. Subtraction. Subtraction. Otherwise, because, okay, why subtraction? Because if you do subtraction, you only have to find one big and one small and subtract. But if you did addition, like in green here, I'm just going to show you, it would be 3 different shapes. You'd have 1, 2, 3. Too much work. No. I'm going to rub that stuff. Bye-bye. Let's do things the easy way. See, again, that's a subtraction. It's just easier that way. You could split it into only 2 shapes. If you did addition, you could do 2 shapes, just to show you here in green again, a rectangle and a trapezium. But no, subtraction, easier. Avoid trapeziums as well. Trapezium formula is tricky. Just, where possible, rectangles, triangles. All right, 3A. I will do 3A. I'll leave 3B to you this time. All right. They're writing the formula first on the first line. That's fine. It just makes the answer longer. So the area, I prefer my way of doing it. Give things a name. That first one, what they're doing is they're doing A1 plus A2. A1 is a square, so the formula is S squared, whereas the next one here in blue is the area of a rectangle, length times breadth, or length times width. I'm going length times width. I don't like length times breadth because B is what we use for base. That plus that, 1 squared, S is 1, so 1 squared plus 3 times, 3 is times, what's the height? The width of this rectangle, sorry, it's 1. 1 squared is 1, 3 times 1 is 3. Well, I prefer my way. No, I'm going to leave that one too. I'm going to pause in 3, 2, 1. And there's the answer for that one. So what they did there, they did subtraction. They did the rectangle, length times the breadth. And then they did the area of a triangle, which is half times base times height. You see I don't like the B's? Because then we've got 2 B's. It's silly. No. Length times width is better. Anyway, what is the length? Well, that's 13, and the breadth was 8. That number came from adding the 4 and the 4 together. 4 plus 4, 8. Minus half times, and then triangle, base, 5. 13 by 8 minus half times 4.5. Put the whole thing in your calculator, but instead they gave you an extra line. 104 is 13 by 8. Half times 4.5 is 10, 94. I'm going to scroll down in 3, 2, 1. Keep moving. All right, so now we're into real questions. We got question 4 here. Not enough room. Not enough room. 3 per page is plenty. 6 is pushing it. How are we going to do this? Going to pause. All right, here's how I'm going to do it. I'm going to make room by not doing 2 of them. And the reason I'm not doing 2 in D and E because they're trapeziums. What's with the person writing this book? Making trapeziums. So I'm going to do question B. I'll put the answer there. F, I'll put the answer over here. C, I'll put the answer down there. And then A, I'll just squeeze in the middle here. So A is the only one which will be annoying. All the other 3, lots of space for them. So I'm going to split it up. Oh my god, A is also a trapezium. Ridiculous. What's with them and trapeziums? Okay, fine. If you insist, let's do it. Let's pretend it's not a trapezium. Got a triangle on top, rectangle on the bottom. Formula for rectangle. Length times width. Oh, the top one's a triangle. Half times base times height. Half times base times the height. Half times where the base is 6 meters. Because that's 6, that's 6. And the height's 3 meters. Done. Rectangle is our length times width. Length is 6 meters. Width is 4 meters. So now I can write out the answer. Area equals A1 plus A2. So half times 6 by 3 plus 6 by 4. Calculator will give us 9 plus 24, 33. But let's check it. 33 meters squared, done. So that's how we do it. I like this way, splitting it up. If you want to do it the way they did it, that's fine too. So C, you split it up. You got a square and a rectangle. B, you got a triangle on top, rectangle on bottom. And same for F. Have a go at those ones. I'll give you everything but the final answer. Pausing in 3, 2, 1. Ta-da! Told you these questions weren't so bad. So I've just gone with C, and I've just shown you the working out. So for C, square plus a rectangle. For B, triangle, rectangle. For F, triangle and rectangle. And I've given you the second last line. Going to scroll down in 3, 2, 1. All right, one more page. Going to pause, make a plan. All right, I just cut out one of them because we don't have enough room. It's C, I cut it. It's a pretty simple one, rectangle minus a square. So we're doing all the other ones instead. I'm going to do A for you, but you're going to have a go at B, D, E, and F. You got plenty of, not plenty of space, you got enough space for those ones. So for A, I am going to be doing a subtraction method. I've got colors, which helps. It is it's too wonky. Third time, it'll do. Call that A1. And then in blue in the corner, green in the corner, we'll make our triangle. So what we're going to do is going to do A1, take away the A2. So area equals, well, no, I'm going too fast. Slow down. What's the formula for the area of a rectangle? Length times width, where the length is 7 meters and the width is 6 meters. Triangle, how are we going to do that? Half times base times height, where the base is 3 meters and the height is 2 meters. Everything's in meters. Good to go. Writing out area equals A1 minus A2. That's the first step. Then it's 7 by 6 minus half times 3 by 2. And then calculator, it's 42, take away 3, 39, but double check it. Half, nope, we'll start again. 7 by 6, 42, minus half, times 3 by 2. We are out of there, 39. Hopefully I said 39. Cannot remember. Units were meters squared. That's how we do it. I'm going to pause, and when you unpause, it's going to have not the answers, but how you get the answers. 3, 2. And there we go. That's how we did it. And for D, you actually had to find those missing measurements, the 5 meters from 9 minus 4 and 9 minus 8. All the other ones, everything was given to you, no unit conversions. E, yeah, you have to see that top and bottom was 20, but that's it. All right, hey, that's how you do it. Just lots of practice this. More practice you get, practice leads to confidence. And that's what you need in maths. You need confidence. Gonna stop here so I don't keep on talking. See you next time.